Well, hello everyone, and welcome back to Adrian's Digital Basement. On today's video, I'm going to be trying to power up the Lisa that I've been trying to revive to see if it has any signs of life. This is part 5 in the series on this Lisa, and if you want to catch up on all the previous parts, of course there'll be links down in the description below. This machine was given to me by a friend of the channel, AJ, and it turned out that this computer had massive battery damage. So when I took it apart, the situation was dire. In the subsequent parts, however, I was able to test the CPU and the RAM board to figure out that those are actually working, and all that really left me with was a totally damaged I/O board and motherboard. That's the main card backplane board that goes in the bottom of this card cage. Well, in the last part, I rebuilt those two cards, which means I actually have the full board set that should result in a working Lisa. So in today's video, I want to take all those boards I've worked on, stick them in the card cage, then pair those with the power supply, which I'll need to check out. And then the last thing is, well, to try to sort out this cable wiring harness situation. And unfortunately, the battery damage that really affected the boards also got to the cable harnesses, because this thing is covered in lots of corrosion, as is the ribbon cable situation. And this is what also you need to interconnect to get the system working. So I still have lots to do before I can attempt this power up to see if there's any signs of life, but I think I should be able to get through that in this video. So without further ado, let's get right to it. If you recall back to part 1, when I took apart the Lisa 2/5 that I've been working on, this is the battery damaged motherboard. And I won't be using this, but just for illustration purposes. This goes in the bottom of the card cage, and all of the various cards plug into this. But for power and for data that gets to other parts of the system, it uses the two card edge connectors. This one is power, and this one is data. The card edge connector on the power supply, this is the one that Alex gave me in part 2, well, these connect up together using a wiring harness like this one. There's also a third connector on this harness that goes to the CRT board, which brings not only the video signals from this to the CRT board, but it also brings power from the power supply to the CRT board. What I'm trying to say is that this wiring harness is absolutely critical for operation of the machine. I can't even power it up without this. This digital edge connector, it brings the signals from the I/O board to the two floppy drives that were possible on the 5/10, even though only one was ever fitted inside the machine. And it also brings signaling to the front power switch and the keyboard jack. That means that I also need this digital connection harness to be good and working so that I can push the power switch to even turn on the power supply, which is all a soft power on circuit, kind of like modern computers today. This is where things become a little problematic for my revival of this machine. This harness, unfortunately, is quite corroded. Now, I've actually already cleaned this. I soaked it with IPA, 99% IPA, and I scrubbed it, but that didn't really take off all the green and crusties. And the worst thing is the green and crusties have really made their way along the wires, because when we take a look at the power supply connector, there's evidence of the crusties on this as well, which is really surprising because I've already cleaned this, but you can see the little blue bits in there. And I have to assume that means that the gunk has actually made its way along the wires or somehow got over to this. So what I think that means is that this harness is not really usable, not without completely remaking it. And that's because this type of corrosion really eats copper, and what's inside of all these cables is copper. And I have to imagine if I cut open some of these wires, especially over here near the motherboard connector, we will see that the wires inside are no longer copper colored, but they're all green and crusty as well. In fact, should we just do that as a test? Let's do that. So let's pick this light blue wire, and I'm going to cut it right here. And let's see what it looks like inside the wire. Okay, well, that doesn't actually look that bad. Oh no, you know what? There's definitely corrosion in there. Absolutely. Yep. That should just be a silver color, and you notice it has a little bit of a blue color. So as I suspected, this wiring harness is entirely compromised, and the battery damage has pretty much taken it out. This harness probably would work if I used it, and like I said, I tried to clean up these connectors, but it's still, the whole thing is just kind of has a weird feeling, and that's the battery corrosion that's leaked onto it. The issue is I don't really like submerging things with wires like this, because the wires have a tendency to wick up any liquids, even water, and then it will just hold it inside the insulation because it has no way for it to evaporate. And that means that it could corrode over time, even from just the water in there, especially mixing with that leaky battery electrolyte that's already inside of this thing. So I think this harness, pretty much, it's a write-off. Well, this is where Jared, who sent in all those barn find Lisa parts for me in the last video, really comes in handy, because he sent me the wiring harness from the Lisa 210, and after comparing this and the other harness together, they're compatible. And when we take a look at this harness, while it's a little bit dirty, it doesn't have any freaking corrosion on it. This is the connector that goes to the motherboard. Looks good. This is the one that goes to the CRT board, and it doesn't look great, actually. Look at that. Why are these connectors so tarnished on this one, and yet the one that connects to the motherboard looks fine, and the one that connects to the power supply, also looks fine. The Lisa 210 harness also has this extra connector, which it's seen better days. It's definitely got some corrosion on it, I think just from moisture. But luckily this plugs into the Lisa internal hard drive, which is only an option on the 210, and I will never be using such a thing. So it doesn't really matter that this is obviously in bad shape. I think this harness will be a good fit to try to revive the Lisa, and I'm quite relieved I don't have to try to rebuild one of these from scratch. A harness similar to this that said it was in good shape recently sold on eBay, and it sold for a pretty penny. That seems to be a common theme for pretty much everything to do with the Lisa. Prices are just absolutely wild. And this is obviously due to a combination of the fact that the machines are kind of rare, but then also they're very prone to destruction because of the battery leakage on the original Lisa and on the 2/5. So I'm pretty confident that this 2/10 harness is going to do the trick for at least letting me power up the machine. I am slightly concerned about the way the pins are so tarnished on the CRT connector, but I wouldn't be surprised if I just use a little bit of a deoxit and a brush. I'd probably be able to make these look a little bit better. I could even use my engraving tool just to kind of scratch up those contacts, just so when I push them onto the CRT board, it'll make good contact. But for the powering up I'm looking to do in this video, it doesn't even matter. I'm not going to be plugging in the CRT. That'll be for a future part. So I just need to make sure that the power supply connector to the motherboard is good, and they both look perfect. The next problem is the digital harness situation. Both of these are the two harnesses I have, well, what's left of them, because I've already taken these apart. This is the harness and its connector that goes onto the motherboard that comes from the Lisa 2/5, the one I took apart in part 1. This is the one that Jared sent me, and I've also taken this apart. The reason why is that both of these were quite corroded and in terrible shape. Now, I took some photographs before I took these apart just so you could see how bad and green and crusty the connector is on the original 2.5 harness. It looked really bad. And I mentioned this in part 1, that when I took apart the machine, I saw that even along the ends of this cable harness, the green and crusties had made its way up the cables as well. Now, unlike the power harness, where I'm just going to use the one that Jared sent me from the 2/10, the digital harness, this one, not compatible. The wiring is completely different, and it's for a couple reasons. One is it just plugs directly into the Apple 3.5-inch floppy drive. There's no interposer board, which exists on this Lisa. So these cables here with this extra 26 pin was designed for a Twiggy drive, but the way this harness was made, yeah, it goes right to 3.5-inch floppy drive. This connector, on the other hand, is for the internal hard drive. So it goes with that extra power connector on the other harness. This is what brings the parallel port signaling to the internal Apple hard drive. So I couldn't have just reused this, but I had a thought that perhaps this connector, which says prototype on it, oddly enough, would have been in better shape than the one that was from the battery damaged one. And using one of these connectors and some fresh new ribbon cable, I'd be able to crimp on the cables and the connectors that I need to make a working harness. Now, when it comes to these two connectors, which obviously these are the important parts to allow me to make a new cable, well, I put these both in my sonic cleaner. After having great luck removing the green and crusty stuff from the boards in the last video, I was hoping that these connectors would come out good, and sure enough, they came out great. As I said, the one that doesn't say prototype is actually the one that had all the corrosion on it, but it actually looks good. It's kind of shocking. Now, it was really difficult to get the cables off of both of these actually, and it kind of bent up these little pins, and I'm hoping that's not gonna make it really difficult to re-crimp this. The prototype one from the Barn Find Lisa didn't have any green and crusties on it, but there is a lot of tarnishing on these pins. Hopefully that won't cause an issue when I try to crimp on the new ribbon cables. To help me remake these connectors, I did take pictures of them when I took them apart, and you'll see here that this is the one that doesn't say prototype on it, but this was absolutely the one that came from the Lisa 2.5, because it has two of these 26-pin ribbon sections, along with a little thin section for powering on the machine. notice that it even was green and crusty on the backside where it was crimped onto the wire. So it's kind of amazing that it came out of the sonic cleaner looking pretty good, actually, pretty shiny. It did remove some of the writing that's on there, but other than that, it came out looking great. Now here's the cable harness that Jared sent me, and it actually has, yeah, it has a little bit of corrosion as well. I guess that's just from the moisture of being in a barn. You can tell that this is the one from the barn find machine because there's some extra space where there's no cables because it has that smaller cable that goes directly to the 3.5-inch floppy drive. Removing the little back plastic piece shows that it doesn't really look like, well, it's not really a great photo. I mean, there's a little bit of corrosion on here as well, but it didn't seem quite as bad as the other one. It's so funny, the wires were so stuck in these connectors that there were little bits of the insulation from the cable still stuck in there after I peeled it apart. I should probably try to fix that since these two are bent over. This happened to these pins when I was trying to peel off the bad cable, the old cable, because it was so stuck onto this. It really just didn't want to come off. But with a little work with the needle nose, I'm able to bend those back into shape, at least for the most part. Part of me can't believe that this green and crusty connector that I'm holding cleaned up as well as it did. It just pretty much looks perfect again. I mean, other than the fact that the pins are a little bit bent up. And the same goes for the one that Jared sent me. These fasteners actually came with the one that Jared sent me, and you notice they are looking a little coppery, and that's because these were all rusty and corroded as well. These went into the sonic cleaner, which removed all the plating. It's better than it was though, and these do work, so I'm gonna have to reuse these, because if you recall from part one, when I took this connector off or tried to take it off, these fasteners were so rusted on there that I had to drill them off to get this connector off in the first place. Now, when I took these apart, I had to kind of figure out how to take them apart since I've never worked with any kind of connectors like this. So there's a little bit of damage here where I had to pry it apart. It really didn't want to come apart. One of these, the clip broke off, and yeah, it's this one here, which I think was from the Jared one. So I think what I'm going to do is I'm going to use this connector, this top piece, and some of this 60-pin ribbon cable, which I don't know where I found this, but I think I'll just be able to peel this apart. Now, taking a look at the lengths that was on the 2/5, that's these ones. One of them is shorter, and I think that's for the first floppy drive, this one, and I think this was for the second floppy drive, this bottom longer one. So that means if I take this 60-pin ribbon cable here, I'll just cut the connector off, and then I'll just make it about as long as the longest piece here, and then I just need to crimp on these connectors and crimp it onto this. Taking a look at the photos, the stripe is always on the left side when the writing, and the writing's only on one side, is facing you. So this is basically pin 1, and there's another pin 1 there and another one there. In addition, the wire goes out of the connector that way. So this is just cut flush, and all the wire goes that way. So when I go to crimp this 60-pin cable on, I'm going to do it the same way with the stripe over here on that side, matching the mark I've made, and I'm going to have the cable going out that way. Now for crimping these, I'm going to use my bench vise. It's the way I always crimp all the types of connectors, like any of these as well. I do the same thing. So what you need to do is get the cable lined up perfectly, and it's not. You can see it's over by 1 that way. You got to get it lined up perfectly, and then you also want to have it lined up so it's perpendicular to the connector. And once it's good, you just put this in the bench vise and you just carefully squeeze it down. You don't want to crush the connector, but you want this thing here to do all the work and actually push the wires over those little tanks. Okay, now to line it up, what you do is you look straight down, you can see the little holes. They need to line up with the wires exactly. So this looks pretty good. So just sort of give this a push down and it loosely clamps it. So you can see pin 1, the stripe is lined up with that hole, and that one there is lined up with that hole. Now what I can do again is double check that these all look like they're going to go into the right spot. They do on that side. And then we flip the cable over and look at the other side. These are some of the ones I adjusted, like over here. It looks pretty good. That one there, that one's not great. So annoying. That one's bent this way towards the right. You know, normally this isn't so much of a problem, just marking the one that's I need to look at. It's normally not so much of a problem because they don't get bent up when you peel the cable off, which is what I had to do to this because the cable was just so fused onto it. I've taken apart so many of these over the years, and I've never had so many issues as I've had with this one. There's that little dot to help me see which one I need to bend back into shape. These needle nose, by the way, I really like these because they are flat. They are not knurled, so it doesn't really put marks on things. Let's try that again. Don't worry about any hanging over the edge like it is here, because you can just cut that off with some flush cutters. I think it looks fine over here. And on this side, much better. I mean, it's still off to the side a little bit, but I don't know. I could fiddle with this forever. I'm just gonna send it, I think. I am just gonna send it. I'm at the bench vise over on a different workbench. I have a couple slot covers there. It just keeps the teeth on the bench vise from really eating into the connector. All right, so I bent over the ears because obviously I wouldn't be able to get this in. So now let's try this out. Just gotta widen the vise a little bit. Okay, we just get this positioned as in the middle as possible. So that just needs a little bit of centering. There we go, that looks good. Sorry, there's not much light over here. I don't normally record, but now the vise is pushing down on it. And there's a lot of cables here, so I have to use quite a bit of force. And you just keep turning till it's flush. I think we're basically there. Yeah, I think we're good. Okay, so there it is. None of the pins came out, so that's excellent. Looks all lined up. What I'm gonna do is bring this over to the other bench and look carefully down into this, make sure I can see all those little metal tangs sticking through these holes. This row looks good. This top row, on the other hand, that looks a little concerning right there. That one looks not quite right. So it's right there. It's 2 over from the blue wire, or 1 over from the blue wire. Everything looks fine on this side though. Well, at the minimum, what I'm going to do is I'm just going to remove the excess here. So I'll just cut this off. And this will allow me to more easily probe what's on here, just to make sure we have good connection between the pins that are inside these little holes and the wires themselves. So I have the multimeter on continuity mode, and I'm going to look for that problematic one. It was this one right here. So it's actually, I'd say that is the blue stripe, that one there, which has a good connection. Then this one there should be the next one over. Okay, cool. Good. Let's make sure. Yeah, that's good. This is all together. That worked. That got recrimped. Cool. There would have been a special tool for doing this back in the day, and a special amp tool, but obviously the bench vise works really well. I've done many connectors like this, and I don't generally have an issue. Right, so the next thing I need to do is I need to look at the photos I took again, and I need to peel this apart into the right sections. There's one for this 10-pin connector, and then 2 26-pin connectors. Now the funny thing is, this 10-pin connector only has 8 conductors. On the other hand, taking a look at these 26-pin connectors, everything is actually through there. All 26 pins go through there. There's not just 25 conductors where it's offset by 1. Now, I don't have any 26-pin IDC connectors, these types of connectors, so I'm going to have to take one of these apart to recrimp, or actually take 2 of these apart and recrimp them. But I do actually have one of these 10-pin connectors. Look at that, you can see the corrosion inside there. Now, one thing that's interesting is usually when you take a look at this, that is pin 1, that notch right there, and yet the stripe is over on the other side. What's up with that, Apple? That's weird. But looking at the 10-pin connector, that little section there is lined up. So it's really just these 26 pins where it's a little unusual, where that notch or whatever that is there, indicate pin 1, is opposite of the actual stripe. Now I can tell that this lighter cable came from the 5/10. Meanwhile, this darker cable is the one that came from Jared's connector. And you notice the notch there, it doesn't even actually have a stripe at all. That's interesting. And nor does it on this smaller connector that went directly into the floppy drive. Does have the notch for pin 1, but no stripes. Back on the photo, we can see the 8 conductors on the far right side, and then we have 26 and 26. The stripe is lined up on all of those. And of course, if you add 26 plus 26 plus 8, That gives us 60, which is the number of pins on this connector. So using the picture as reference, I know that this stripe is pin 1 on the connector, and I need to count 8 conductors on this side and tear this off, and that'll be for the small IDC connector. So 1, 2, 3, 4, 5, 6, 7. Oh, that's the wrong number. I think this is right there. 1, 2, 3, 4, 5, 6, 7, 8. Okay, so there's our 8 conductors for the small ribbon cable. Before I tear this the whole length, I'm just going to find the 26 pin middle and go from there. I know I'm talking a lot about this, but you just have to be very precise about doing this, because if I crimp one of these on the wrong way, it's gonna, I don't know, could damage things actually. So I really have to be careful making this cable. I gotta do it perfectly. Okay, so these lines are every 5. So that means it's 5, 10, 15, 20, and we're going to 26. So it should be 1 additional conductor after this wire. So I just put a little hole there, and I'm just going to count these manually just to make sure. I'll count them more than once. 26. Okay. So I think this is correct. Now I'm just going to count the number on this side, and it just helps to kind of bend it over and count the little copper conductors that you see. 26. Okay. So we have 26, 26, and then the additional 8 for the small IDC connector. Now again, looking at this connector, we know that's the first stripe. Then there was another stripe over here somewhere on the original connector. And then we had one that was on the left side of those 8 conductors. And if I go to the end, I used a marker to mark those extra stripes. So stripe, stripe, and stripe. And that means I can replicate this connector with this brand new IDC connector right here. And to replicate it, basically it was like this. And this stripe is all the way over on the left side, which is essentially this, what we're seeing. That will replicate this connector. There's the pin 1 mark over on the left side. And when we take a look at this one, there's the pin 1 mark over on the left side. So I'm just going to go to the bench vise and crimp this down. I'll do it the same way I did the other large connector. There we have it. I'm back from the bench vise. It's crimped on. So I'm just going to carefully peel this away. And obviously this is way longer than the original one, which was just that long, but whatever. I don't think that's really going to matter. Now, as for the 2 floppy drive connectors, I actually don't need to worry about that for this bench testing, because I'm not even going to plug in the floppy drives. I just want to see if we have a splash screen. So I will leave these off. What I'm going to have to go do, because I don't have any of the little IDC connectors for 26 pin, is I'm either going to, well, I'm not going to touch that one. That one's bad, so we can forget about that. But I might actually steal these, maybe the one off Jared's cable as well, or I'll steal these off of a parallel or serial port from a PC. It's all the same. And as long as I crimp them on the same way, then those should work as well. Right, so I'm nearly there. Between this harness that Jared sent me and this cable I just made, that should be all I need when it comes to bench testing the computer. The last thing I need to work on is I need to take a look at this power supply. I got to open this up, and we need to look at this and see if it's been converted to 120 volts and see if anything looks out of the ordinary, if there's any bad solder joints, stuff like that. When Alex gave this to me, he didn't let me know if this had been tested or not, so I really don't know if this actually works. So I've serviced lots of power supplies on this channel, and I think the first step is just going to be opening this thing up. Looks like there are some fasteners that go all around the edges, and then I think this sort of comes apart like that. I do have to throw out the caveats out there that working on a power supply is potentially dangerous. This thing hasn't been used in months and months and months at the minimum. So there's no danger of any capacitors in here holding any kind of charge. That's the concern you have when you work on these types of power supplies. Of course, if you're going to run one of these power supplies with the cover off, it's even more dangerous, because then you have mains voltages floating around in here, plus high voltages that are rectified DC and stuff, and it's all somewhat lethal. So please only work on these types of power supplies if you know how to do so safely. That fastener was actually loose. All right, so with those fasteners out, this just slides out, exposing the inside guts of the power supply. On the top cover, there are these little foam pads which hold that PCB and I guess that heat sink from wobbling around too much. Let me just take a look inside here, see if anything looks out of the ordinary. So far, everything seems fine. This diode over here is kind of in a weird, precarious spot. I don't love how these diodes are so close to each other. Let me find a screwdriver and try to split these apart a little bit. That is suspect. So we'll just bend them like that, and just so they are not touching each other. And same for this one. Just bend this over. There we go. That makes me feel a little bit better, just slightly better. There we go. So generally the way this works is the mains comes in, we have some filters here, inductors, inductor, capacitor, inductor. That makes its way over to the main part of the power supply. These are going to be the switching transistors that switch. This is the main transformer. And then we have some voltage regulation, some more inductors, and then these are the main caps, the filter caps for the switching side of this power supply. When it comes to the 120 volts versus 230 volts, we can see right there the way it's supposed to be hooked up. So it looks like if you have a jumper link from there to there, that's for 230 volt operation, or from here to here and here to here for 115 volt operation. So indeed, this has definitely been converted for 115 volts already. And that's what Alex said. He said he might have done that conversion. And it looks like that was the case. A few interesting things about this. It looks like we have a little micro switch here, which obviously is pushed when the cover is put on. So that probably shuts off the entire power supply if the rear cover has been removed. So we'll definitely have to bypass this to do the bench testing. So just FYI, there's also another one of these micro switches on the front cover that you have to worry about, and that probably will need to be held down as well. Both of these will have to be closed. Looking at this, the caps seem to be okay. This cap is not really near stuff that's going to get hot, so that's excellent. This little board is probably a voltage regulation board. Nothing looks burned or bad on it. That's what I'm looking for, is any burn marks on the PCBs or dark spots on the PCBs. These caps on the output side, they're not leaking, they're not bulging. They are probably fine. Looks like over here we have one more jumper that's required to be set for 115 volt operation, and that has already been in position as well. Excellent. I don't see anything that looks bad on this power supply whatsoever. I think this power supply probably just works completely fine. And if you are a regular watcher of my channel, you know that I am not a proactive cap swapper. These caps are from 1983 and are probably better quality than anything you could buy today. And they're not from the 90s where everything went to junk. These are from the 80s, and I'm going to say, so I'm going to leave them alone unless this power supply presents some kind of an issue and doesn't work properly. Then I'll dig deeper into this. I think maybe the only thing I might need to do is maybe a little bit of lubricant in these pots. I'll do that now since I have the cover open. They still feel fine. They turn without issue, but I'm going to hit these with some contact cleaner. Getting with some QD electric cleaner. This stuff here. It's funny, they were a little bit gummy, and now with the cleaner in there, they turn very, very, very freely. Once they dry, I add some of this deoxit fader lube, which has lubricant in there, just to kind of restore the lubrication that is originally inside of these pots. Just move it back and forth, just spreads that lubricant in there. Yeah, these are feeling pretty good now. One potential issue I could see is maybe a cracked solder joint on the bottom side, but I just don't feel like taking this thing apart fully right now. So I'll just leave these be, and we'll see if the CRT acts funny, then it might be an issue with these two pots. There we have it. This power supply is back together, and incidentally, it's from 1984, not 1983. And I guess, I think that's it. I think I'm ready for testing. So I kind of can't believe it. Let me get set up. Well, that is progress. I have the power supply connected to the harness, which is connected to the motherboard. I have the ribbon cable connected, and here's the power switch plus keyboard jack. The card cage, which will align these cards, is actually screwed into the PCB on the left side. Right side is just floating. Now it should all be attached to this plate. This was what's inside the computer, but it's in really rough shape. And I don't feel like putting any of this stuff onto here until I have a chance to clean this, and I'm gonna have to do a bunch of scrubbing and whatever to get all that corrosion off. Luckily, I think this is aluminum, so it's not like this is actually rust on this metal. It's just a lot of oxidation. Should be able to get that off, but I just don't feel like doing it right now. So for now, this is just sitting on top of this mouse pad, and I have a screw on this side of the card cage because it's floating just to hold it up. Now for the ribbon cables, I wasn't sure which way they went on, since of course they could go on either way. For the harness that goes to the power supply, it's kind of obvious just because the wires here are sort of formed into the right orientation to go to the CRT board. That's what this one's for. It made sense that these wires go to the left to go over to the power supply. As far as the ribbon cable goes, well, it could go on either way theoretically, but this is the way that makes the most sense, with the little 8-pin ribbon cable over on the left side. So I went back and watched the video on disassembling the Lisa, and I could see that the little 8-pin section is over there on the left side, and there's no writing on the top of that connector And this one you can't really tell, but obviously I can see that the wires here go up to the CRT board and they go over to the left to the power supply that's not currently installed. So that is why I wrote up on both of these, so when I assemble the machine, there won't be any confusion on which way this goes in. For the initial power up, I thought it'd be a good idea to hook up the speaker. Now this was the one that Jared sent me, and it's looking really, really rough. If you saw the video where I tried to test a CRT with the Macintosh to see if it was a good candidate for going into the Lisa, when I took apart the rest of that TV, it turned out that, well, it had a perfect speaker that is exactly the same size as the original. The impedance is 3.2 ohms versus 8, so it might be slightly louder, but the other potential issue is just a clearance issue. I didn't even notice that it's quite a bit taller, so maybe inside the case it won't fit. I did take the multimeter to this speaker though. It does seem to be working. I hear a little clicking on diode check and it registers about 7.8 ohms with resistance check. So it does work even though it's in terrible shape. So in case this actually works, I just connected it to the harness and I'll just set it back there because maybe there's a beep or something that comes out of this computer. I actually don't really know. Now, as I mentioned earlier, there are 2 interlock switches. This is the one on the power supply. I just jammed a Q-tip in there. That's holding it closed. And on the back cover, there's another switch. I just put a zip tie around that one. So as far as the electronics are concerned, this Lisa is all buttoned up with all the panels installed. Yes. So I have to say, I'm quite nervous about what I'm about to do. There's so many variables here. I don't know if the power supply is working. This harness, I have no idea if it really works. I made this cable, I made the motherboard. There's just a lot of stuff going on here that there's a big potential for problems. I think the first thing I'm going to try doing is just powering on the system exactly like this with none of the boards installed. My presumption is nothing will happen because without the I/O board, which I think is what controls the power supply, it's not even going to turn on. But perhaps it's the right thing to do just to see exactly what happens here with none of the boards installed, just in case magic smoke comes out of the power supply, for instance. So I'm going to plug this in. The power is currently off to this cord. And I have a power strip over on the left side just off frame. I have my finger on that button and I'm going to turn this on in 3, 2, 1. Right, power's on, nothing happened. That's not a bad thing. I'm just going to listen inside the power supply for any noise. I just heard a little bit of a click when I turned off the power switch, so it sounds like power is getting to the power supply, and I'm glad nothing else happened. So I suppose at this point, maybe it's time to just install the boards and go for broke. So this is the I/O board going in and the power is off. In fact, just to make sure, I will unplug the power cord. There we go. All right, let's give it a good old push to get this down and into the board. There we go. That is fully seated. Next up, the RAM board that I tested with Alex. Okay, RAM board is installed. And lastly, the CPU board, which I also know works because we tested this at Alex's place as well. And I remember from testing with Alex that this CPU board is slightly bent. So it requires a little bit of extra work to get that in. So I'm going to pull out the I/O board just so I can see the connector. With the I/O board out, I can see what's going on here with this. There we go. There we go. The CPU board is in all the way now. Let's check the RAM board. That's still in. And now this rebuilt I/O board. And there we go. That's the I/O board in. All of the boards are in the system. Question is this thing going to work or something catastrophic going to happen? Okay, here's the power cord. It is currently turned off. And I'm just checking the camera. It is recording. This is really the moment of truth here for the Lisa. So much hard work has gone into this thing. Is this thing going to come to life? Here we go. 3, 2, 1. Well, nothing happened. Push the power button. Okay. Well, there was a click out of the speaker. I'm going to turn the power off. Does this power light work? I suppose something that's good here is that no smoke came out of anything. So that's something, I suppose. I have attached to that cap right there. I don't know what voltage that is, but something should appear there. Let's turn this back around and I'm going to turn the power back on. Okay, we're getting kind of just nothing. And I'm going to push the power button. Okay. There was a click out of the speaker, and every time I push it, there's a click, and then it goes away. I'm going to switch this to manual ranging because it's a little bit faster at displaying when it shows a voltage. Yeah, it's not really working. The system is obviously not starting. All right, incidentally, I just turned on the power supply with the system off, and I am getting 5 volts on this cap. So that's something. Let me try turning on the computer now. That doesn't really change. This cap over here is dropping. Try to turn it on, nothing really changes. Oh, it does go up initially. This thing is just too slow to really show that. So the power supply is definitely supplying power to the I/O board. So parts of this are working, but it's just not able to start. Now, is this my fault for putting these large caps on this board? And maybe when this power supply tries to start up, it considers a short because there's too much load? Or is there actually a short somewhere on this board? Which is definitely quite possible. What I'm curious about, and I just shut the power off, is if the computer will try to start without the CPU or the RAM board installed. Because I know these aren't shorted, but maybe the additional load is potentially causing an issue. So without these 2 boards putting load on the system, maybe the power supply will actually start up and stay running. Right, so I've clipped onto that cap. I think that was one. Yeah, that doesn't really get voltage without the system being on. So I'm going to push the power button now. Okay, so I'm not exactly sure what this cap is doing. I might have to check the schematics. Seems that the voltage on there sort of drops to 0 for a second when I hit the button, and then it comes back up. And the whole time, there's no light on the power switch, but that could be bad theoretically. Next, what I've done is clipped onto the VCC on one of the 6522s. We'll see what happens when I power on the system. Interesting how there's a little bit of voltage there. And when I push the power button, there might actually be voltage appearing on the board for just a second when this thing tries to turn on. I need to set this to oscilloscope mode because this thing is so slow as a multimeter. Let's change this to roll mode. Ah, look, there it is. Okay, so it's actually going higher than I even thought it was. Is that voltage actually is going higher than 5 volts? So we're at 1 volt per division. So if we look at the yellow line, 1, 2, 3, 4, 5, that would be 5 volts under the time there. When I push the button, it goes above that. That's concerning. That is concerning. Just to make sure that I wasn't on a different voltage rail, I've moved the ground lead over to the ground pin on that 6522. Let's see what happens now. Same thing. That is very concerning. I hope I haven't caused any damage by, well, that whatever voltage spike we're getting there. So I have it set for 2 volts per division. Let's just try it one more time. See how high it goes. It was around 6.5 volts. I don't think that's really enough to damage anything, not for that short burst, but it's certainly not good for it. Well, I think at this point, I really need to focus more on this power supply. So I'm going to disconnect everything, and I'm going to try to figure out how I can run this with my DC loads and try to figure out how to turn this on, because I really need to be able to see to make sure this is actually regulating all the voltages. I hope I didn't damage anything. If I did, it's not like it's not fixable, but that is very concerning. Okay, here's the setup I'm going to use to bench test the Lisa power supply. I probably should have done this from the start, but I had to cut the harness to facilitate this, and I cut the one that was corroded. I didn't really want to do that, but I guess it doesn't really matter, so I cut the harness, and then I figured out exactly which color wires go to which voltages. So plus 12, plus 5 ground, minus 5, plus 5 standby, minus 12 power on signal, which basically you feed the 5 volt standby into, and that turns on the power supply, and then plus 33, that's used for the CRT. I have the electronic load connected, and I currently have the 12 volt rail, which is channel 1, set to 3 amps, and I have the 5 volt rail, which is channel 2, set to 5 amps. Incidentally, the power on signal, which is the gray wire, goes through one of these interlock switches. So without the front cover on, this is the front cover interlock, then there's no way the power on signal can actually get to the power supply. And it's this green wire that goes down to the motherboard, I suppose. I have the multimeter connected up to the 5 volt standby output, which happens to be the white wire with the yellow stripe. And I have this clip lead ready to go, and all I need to do is clip it onto where the red probe is here. That is the 5 volt standby, and that should turn on the power supply. So first thing I'm going to do is apply power to the power supply without actually turning it on. And let's see exactly what happens. We're getting 5.5 volts, which is correct. According to the schematics, which I found for the Data Power Inc. power supply, it should be 5.7 volts, but voltage drop and whatever, that's completely fine. By the time it gets through to the I/O board, through the traces and stuff, I'm sure it's going to drop a little bit. So really at this point, all I need to do is hook this clip lead up to the power on signal, which happens to be the standby 5 volts, and that should turn on the power supply. I'm going to turn off the power supply first. So there goes the standby voltage. I'll clip this on like so. And when I turn it on now, the power supply should start. Channel 2, we should see around 5 volts, and channel 1, we should see around 12 volts. All right, here we go. 3, 2, 1. Right. Okay. So it just shut down immediately. And we turn it back on again. There's a little bit of something that comes up on there, and this is still at 5.5 volts, but definitely we're not getting anything out of the 2 rails. So I think what I want to try doing is switching this back to oscilloscope mode, just like we were before, and let's see if we have that same spike when it first powers on. Because I'm thinking maybe the voltage regulation circuit in the power supply is malfunctioning. Just trying to get it so that shows up in the camera. Okay, here we go, 3, 2, 1. All right, well, we get a little bit of a spike and then it immediately stops. Let's try turning off the load and let's see what happens when I turn it on now. Oh, it's actually running. That is interesting. All right, I've actually shut the power supply off right now. And let's try that one more time. So this actually does show you what voltage is, even when the load is off, that the 2 channels are running at. So it looks like the power supply under-regulates when there's no load. Perhaps the load I had set was too great. I guess I can turn down the load on channel 2, that's the 5 volt rail, and I'll turn it down to 1 amp on the 12 volt rail. Okay, let's see what happens now. Nope, same problem. Maybe we're underloading it. So I will try turning that up. So I'm gonna make it 5 amps on the 12 volt rail and 7 amps on the 5 volt rail. Here we go, 3, 2, 1. Nope, just a spike, and it immediately shuts down. Let's try 9 amps on 5 volt rail. Again, totally unhappy. I'll turn off the 12 volt channel, so it's only gonna be on the 5 volt rail now. That made no difference. I'll try 3 amps on the 5 volt rail. Again, nothing. 1 amp on the 5 volt rail. It can't even supply 1 amp without shutting down. What's really curious, if I turn off the load entirely, then it does run. It's just the voltage is too low. But even if I just put it to 1 amp, it can't run. Through the top lid of the power supply, there's a hole with a potentiometer, and I'm assuming that's for 5 volt regulation. And currently, it is actually set all the way to 1 extreme. So that could easily be our problem. So it's currently set to 5 amps, and we turn on the power supply. Yep, we're getting the same spike. So that's fine. Let's turn it to some other position. I just turned it some amount. Turn the power supply back on. Look at that. Whoa, it ran for a little while, and then it shut off. Well, that's something. Let's give some load on the 12 volt rail as well. Maybe not 5 amps, but how about 2 amps? And how about on 6 amps on the 5 volt rail? Hey, it's running. Let's turn it up a little bit, or down. I'll get it to like 5.1 volts. I don't know, 5 volts. So 30 watts and 24 watts are coming out of the power supply right now, and it's running. It is freaking running. Well, that's great. That just means that potentiometer was the problem the whole time. So I'll turn the power off, and let's see if this comes back on without any issue. This thing has comparators inside just to make sure that it's running within spec, and it will shut down if it detects that any of the voltage rails aren't working properly. So we'll turn that on. There we go, 5.05. Now we're measuring the voltage after the voltage drop of these wires. And of course, I'm not using the thickest wires in the world. And I didn't even connect it to all the various wires on the connector. I just sort of bundled a few of them together and put them inside this spring-loaded connector here. So again, 30 watts on the 5 volt rail and 24 watts on the 12 volt rail. And now it's working. It is absolutely working. Let's pull the clip lead off. That's going to shut the power supply down. There it is. It just immediately drops. And we'll turn it on. I'll clip it on. There it is. Yes, yes. Potentiometer was just out of adjustment. And I'm glad I was able to get this set up so I could do this test now, just so we could make sure the power supply was working before I went down any other rabbit holes. Let's put this back to DC volts and let's measure a couple other rails. So there's a blue wire here, which according to my notes is -5. So let's see what we get on that. -5, perfect. Then we have a white with blue wire that should be, according to my notes, -12 volts. So here we go, power it on, 3, 2, 1, should be -12. There it is, 12.9, that's absolutely perfect. And while we're here, why don't we test the 33 volts on the CRT, which is in this little bundle of wires that I bundled up here. It is white with red. When I turn this on, oh, wow, it's sitting there at 57 volts. And this is off right now. That's wild. 60 volts? I'm feeling that without a load, that rail, it kind of goes out of control a little bit. Yeah, hopefully that doesn't over voltage the capacitors that are in here. I don't know what voltages the capacitors have on that B plus rail, but I might want to put a resistor on there just to load that down. This is the setup. Power supply is reconnected to the motherboard through the harness, the original harness, the one that's not cut up. Power supply is connected to the mains, but that's currently switched off. I currently have this multimeter connected to the 5-volt rail. These two caps are just on the 5-volt rail, and we'll be able to measure that. That's the switched 5-volt rail. And I do have the electronic DC load hooked up to the 33-volt rail for the CRT, and I have it set for just 100 milliamps, so we can see how much voltage is presented when this is turned on. It's currently at 0.7, even at 100 milliamps. Oh, let's turn on the load. Okay, there we go. We're down to 500. Now, currently only the I/O board is in, and I talked to Alex about this, and he said that if you have the CPU board and the RAM board in without the I/O board, the system should all just turn on automatically without this in there. You won't really get a working system, but you'll kind of get a working system. The video is actually produced by the CPU board, not by the I/O board. So maybe, well, I'm going to put all the boards back in, so we'll just test this as a complete unit like I did the very first time. CPU board, RAM board, and I/O board are all installed. I think we're ready for testing. So theoretically, when I turn on the power switch over here, the standby voltage should suddenly be available to this, but the system should not turn on. Only if the I/O board is removed would the system just turn on immediately, or if it's damaged or something. So it should stay off until I push the button, and then everything should turn on. So here we go, 3, 2, 1. Okay, nothing's really happening. Are we ready? 3, 2, 1. Okay. Well, the system is running. We're at 4.9 volts. The light's not working here. We have 36 volts on the CRT output, so that's running. The power supply is definitely working. Do we have an image? I don't know, but I would say that our power switch is definitely has no light. In fact, let's just try to push this and see if we can turn off the computer. Oh, it turned off. It took a second, and then I heard a tick out of the speaker, and then it did shut off. All right, let's try this again. Power on, 3, 2, 1. 4.9 volts. All right, it's working. The voltage is a little bit low because I'm measuring this on the I/O board itself, but that's fine. Everything should be working with that voltage. I guess the question is now is, are we getting an image out of the composite video jack? That's what I need to test. So for testing that out, I'm going to use the RGB to HDMI, and I have the comparator board that allows me to use composite. So RGB to HDMI is there. I have this blue cable connected up to the RCA jack. Let's plug this in. I'm not in the right profile, but oh, we're getting some image. This is good, everyone. This is good. Oh, there's an Apple Lisa profile. Oh, it's rolling, but I see there's stuff there, a gray background. Oh, wow, I cannot believe it. I definitely see we have some kind of dialog box up on the screen. It's just everything is all slanted, obviously, and not working quite right. I think there is no sync information contained on this RCA jack, and this could have been easily something that I did the way I wired up the jack or the circuitry that does the sync combination. I should look at it with the oscilloscope because it doesn't seem like it's getting any sync. Right, what we're looking at here are actually horizontal scan lines, and that's the horizontal sync pulse, which seems fine. In fact, if we keep zooming in, you can see the gray background pattern, the checkerboard pattern that makes up that gray background. So that's what that is. And so again, horizontal scan lines. So if we zoom out, these are all the different scan lines, and we keep going out, we should be able to see the actual frames. So these pulses there, those are the vertical sync pulses, and I can see them, but for some reason, RGB to HDMI is not able to pick those up for some reason. After much fiddling, I can't get this video output to work properly. It just won't get the sync on the RGB to HDMI. So I'm going to bypass the whole thing, and I'm going to clip right onto that 74LS132 that's on the motherboard, and that buffers the sync and the video signal, and I'll just go directly in to the regular DE9 RGB to HDMI. Okay, I've switched the RGB HDMI into the Lisa profile. I'm sure I'll have to do some amount of fiddling, and turn on the computer. Aha. Did not turn on there. It turned on and then it turned right back off again. What's going on? Huh, it turns on and then turns off. Did I do something to the machine to make it unhappy? I'm just checking everything. Okay, DC volts, let's try this again. Now it works. I just sort of moved the cables around on the backside. Huh, okay. Yeah. Oh, look. It freaking works. It freaking works. It's doing the diagnostics. Testing. Oh, it says 57 is the error. Interesting. I/O. I'll have to ask Alex what that means, but I can't even believe it. I can't even believe it. You know, it's funny, when I was testing with Alex, I kind of remember his I/O board was doing this 57 thing as well. Huh. Well, I'm going to turn off the computer here. I'm going to push the power button because I want to plug in a mouse. I want to see if I can move that mouse pointer around. So in goes this Apple mouse. This is one of the platinum ones. Hopefully that isn't the problem. All right, here we go. 3, 2, 1. It stays running. I don't know what was happening before when it wasn't staying running. Okay. CPU checks out. It's doing a RAM check right now. And then it does the I/O board diagnostics. Okay, and there's the mouse pointer. It freaking works too. What? Start up from. Wants a floppy disk, which of course there's no floppy drive currently connected. I cannot believe this. I really can't believe this. It's working. No disk. Yeah, error 23 apparently. Yeah, all right. Amazing, absolutely amazing. I tried to reset the machine right now, but I don't have a reset button connected, so I can't do that. So all I could do is push the power button, which after a second does shut down. We just get a white screen. That's normal. The TTL outputs are inverted. Push the power button to turn it back on. I still can't believe it. I just can't believe it. Wow, absolutely wow. Obviously this is a expansion card, which I don't have any installed. Still, I'm shocked, just shocked. There it is. Yeah, what is 57, I wonder? Like it's a check mark with an X through it. No, you're bad somehow. Well, I think that's going to be it for this video. I am completely shocked that this thing is working as well as it is, especially after all the damage that this poor I/O board went through, the vandalism, and, you know, it's showing signs of life and the mouse is working. I mean, who knows about these other components and stuff, but still, it's working. So theoretically, at this point, if the CRT board that I have two of them luckily, one from the battery damage machine and one that Jared sent me, if those CRT boards work and the actual original CRT is not so worn out that it's massively dim, if I put this back into the case, then we should get that. That should work. And I did actually get the keyboard adapter that I need to run a keyboard on this. It uses a Mac Plus keyboard or a Mac 128 keyboard, so I have that. And the mouse is obviously working. So theoretically, with a working floppy drive and a working profile, and I do have the emulator, then I could get into the Lisa OS which I forgot the name of right now, Lisa Workspace or whatever it is. Anyways, I could get into the Lisa OS and actually experience Lisa for the first time. Wow, absolutely wow. All right, well, I'm gonna end this video here. If you enjoyed this series so far, thumbs up. I'm relieved this is working. Huge thanks to Alex, who's really helped me out with a lot of the stuff on this, of course, giving me the power supply, which I really needed, and the motherboard replacement. And then a huge thanks to Jared for sending me all those parts, the wiring harness I'm using, along with the I/O board, which I've repaired, hopefully, and it's up and running. If it wasn't for both of them, I would have had so much more work to do, and really saved me a whole ton of time. What's kind of amazing to me, I'm still reeling that this is working. What's amazing to me is that a bunch of the components that I put on here, I took off the battery damaged board and they're working. And obviously with these larger caps on here, I thought it might be a bit of a problem because I did look at the schematics, by the way, after the last part, and some of these are used in some timing reset circuits. That could explain why it takes so long for the system to power up. Although I remember now testing the CPU board at Alex's, and it was slow to start on his machine as well. That black screen that we see when we first power it on is longer than it maybe should be. And that was with his I/O boards with the correct caps on there. But obviously with these larger caps, I guess it really wasn't an issue. And again, the power supply issue that I ran into earlier in the video was just simply because the voltage regulation pot was turned all the way up, which probably ran it too high of a voltage and just shut down. So anyhow, if you like this video series so far, I think I've said that twice, thumbs up would be appreciated. Subscribe if you haven't already. Huge thanks to my supporters to make it possible to do this full time. Without their help, I wouldn't be able to do this full time. I'd love to hear your comments about this whole series down below, and I guess that's gonna be that. So stay healthy, stay safe, and I'll see you next time. Bye-bye.